Hey, welcome to the next in our audio tutorials. Today we're going to talk about frequency and period. These are two of the 8 properties of audio waves, and we're going to talk about them together because they're interrelated. So frequency, let's do frequency first. Frequency is equal to the pitch of a note. So if I have a space of time that is 1 second long, the frequency is how many times it completes a whole wave. So if it goes like that, that's 4 waves. So this would be 4 hertz in 1 second. Okay, if it was something more like this, then I don't know, is that 12? Something like that would be 12 hertz, 12 waves in 1 second. Incidentally, none of us can hear anything that is 12 hertz. That is too low for us to hear. These waves are really long. If we want to be able to hear it, the lowest frequency we can hear is, here, let's delete that. The lowest frequency humans can hear is 20 hertz. And then the highest frequency we can hear is 20,000 hertz. But once we get into the thousands, you don't use hertz anymore, you use kilohertz, because that means 1,000. Okay, so this is the range of human hearing, and that's like when you have perfect ears when you're a little kid. The older that you get, the more you lose the ability to hear, especially these high frequencies. Let's see some examples of this. Oh, no, first let's talk about period. Okay, so frequency is the pitch, period is the time that it takes for one wave to completely cross a line. So if I'm standing right here, yeah, and here's a sound wave coming at me. Actually, we just want one wave. That's how we measure. Okay, there's one sound wave. It's coming at me. How long does it take for this point, for the whole wave to cross through me? That's how we measure period. And we measure this in seconds or in milliseconds if it goes really fast. So if it takes 1 second for the whole thing to go through me, then that means it is 1 hertz. Okay, if it takes 1 millisecond to go through me, that means it is 1 kilohertz. That means it's a really small wave because it can go through me real fast. I should also mention that the standard way of writing frequencies, so if you have a frequency of 220 hertz, it's with a capital H, the lowercase z. If you have kilohertz, 12 kilohertz, capital K, capital H, lowercase z. Okay, so this is how you should always refer to frequencies. So here's the equation to figure out the relationship. So the time, or the period, equals 1 divided by the frequency. So that means if I'm trying to figure out the time, and I know that the frequency is 20 hertz, then what is 1 divided by 20? Well, 100 divided by 20 is 5, right? But then there's some decimals. 20 into 100, so that goes 5, so it's 0.5. 0.5 seconds. Is that right? That doesn't seem right. Oh, geez. Yeah. That's why. That's why. It's not 0.5. 20 goes into 100 5 times, not 10. So there's a 0. Okay, so 20 hertz is 0.05 seconds. So the time equals 0.05 seconds. And then that's a weird number to refer to in seconds, so instead let's convert it to milliseconds. So we need to move it over 3 times, which means that equals 50 milliseconds. Okay, maybe before this we should talk about how these units work together. So 1 second equals 1,000 milliseconds. So that means 5 seconds. How many milliseconds is that? 5,000 milliseconds. Milli means 1,000. So to convert it, you take your number in seconds and then you add 3 zeros at the end. 1, 2, oops, 5, 1, 2, 3, 5,000. Okay, so actually you move the decimal over. So if it's a whole number, that means the decimal's right here. So you move it over 3 spots. If it's not a whole number, if it was 0.5, I still move the decimal over 3 spots. 1, 2, 3, and I add some zeros. So now it's 500 milliseconds. If I was 0.05, let's move the decimal 3 spots. 1, 2, 3, add a 0 in there. Nobody writes 50 with a 0 in front, so that's just 50 milliseconds. Okay, so hopefully you understand that. Let's do the opposite now. So if I have something in milliseconds, how do I convert it back? Well, here, the decimal's right here, right? So I move it backwards 3 spots. So now it's here. So that means 1 second. If I have 100 milliseconds, here's the decimal, I go 1, 2, 3, so that makes it 0.1 seconds. If I have 10 milliseconds, here's my decimal, I go 1, 2, 3, have to add a 0, 0.01 seconds. Okay, so you're going to need to practice this whole thing a lot if you don't know how decimals work, because that's how you figure out the time for these things. Okay, so let's get back to our equation. Time equals 1 divided by the frequency. Okay, so if my frequency, and go ahead and use a calculator on these things, who cares? I mean, if my frequency is 440 hertz, I don't know how to divide that. Good grief. So we'll just go over here and, where are you, calculator? There. 1 divided by 440. We'll round that down, 0.002 seconds. Okay, time equals 0.002 seconds. And let's write that, let's convert it to milliseconds because that's how it works. So let's move this 3 times, 1, 2, 3, 2 milliseconds. Alright. Now, the opposite works the same way too. If you want to find out the frequency of a wave, frequency is 1 divided by the time. So if I know that my time is 1 millisecond, so if I'm dealing with milliseconds down here, then I need to deal with kilohertz up here. Okay, so this 1-to-1 thing, if it's kilohertz, then it's milliseconds. or if it's seconds, then it's hertz. Okay, so if I have milliseconds down here, I know my answer needs to be in kilohertz. I can always convert it back afterwards, whichever. So let's just undo all this. So that means 1 millisecond. So what's 1 divided by 1? It's 1. Duh. So that means 1 kilohertz. 1 millisecond is 1 kilohertz. Okay. If it was 5 milliseconds, then it would be 1 divided by 5, and as we know, that is not 20. Or is it? 0.2. It is 0.2 is what it is. So that means F equals 0.2 kilohertz. But you don't talk about kilohertz in decimals, so we need to figure out how many hertz that is. Let's move it back 3 spots. 1, 2, 3. So that equals 200 hertz. Alright, let's try another one. We'll go with an even smaller number. So if our frequency is 1 over time, and let's say that our time is, let's give it a really small number, 0.023 milliseconds. Okay, so that means that's super fast. 1 over 0.023 equals, so here remember we're using milliseconds, so we're going to have to convert it into seconds after that. Let's go to our calculator. 1 divided by 0.023. So that's how many kilohertz it would be, not hertz. Frequency equals, come back up calculator, 43.47 kilohertz. We'll just say 43. Okay, so if you start out with milliseconds, you end in kilohertz. If you want to convert it either way, so that would be 43,000 hertz. Alright, now let's look at some examples of how this works. So I'm going to generate some waveforms. Effects, generate tones. So this will be a perfect sine wave. Right now it's starting out at 880 hertz. Let's start out with 100. Okay, that's what a 100 hertz tone sounds like. I'll hit OK. There it is. It put it right in there for us. Now let's go to the end of that, and let's do an octave above that, 200 hertz. So that means this wave goes twice as fast. And then at the end of that, let's add one even higher. So let's go up to 400. And then let's double that. So every time you double it, it's an octave higher. And then I'm not going to add the rest of these, but we'll just play them for you so you can hear. Let's try 16,000. No, 1600. You won't be able to hear 16,000. Can we go twice as much as that? Ooh, that feels good. Octave above that. That sounds great. What's twice this much? 12, 8. You ready? Plug your ears. Oh yeah. Put that on when you want to fall asleep. Okay, and then twice that we're not going to be able to hear. It's beyond human hearing. We could try, let's see how high we can hear though. 16,000. There's 16,000 right there. I can hear it. Okay, so if you want to play around with frequencies, just open up Audition, go to this frequency generator, and see what you can hear, what they sound like. So let's go back to these ones that we added. Okay, so if I zoom in on it, so here's our starting one. Notice how when the 100 is twice as big as the 200. And then once it gets to the 400, it'll be shrink even more. Okay, so there you go. That's frequency. How many times a second these waves go through. Alright, so that should cover it for frequency. We've got some problems for you to practice on, trying to convert the time and the frequency back and forth. So good luck. We'll catch you next time.